Hello, and welcome to a little video about Target 2A, where we will be making connections between arithmetic sequences and linear functions. Now, the first thing I'd like to do is mention that we are no longer really going to be referring to slope as slope in linear functions. We're going to be referring to it as your average rate of change. Now, the reason we're changing the language that goes with it is because average rate of change is kind of the little tiny area of slope between 2 points. However, these 2 points can be on any type of graph, like the one that I have up here for you that's U-shaped, that's a parabola. We still have a little tiny slope between 2 points, but because it's not a straight line, it's a U-shaped curve, we're going to call it the average rate of change. So it's the change up and down and side to side that's happening between one point to the other, left to right. Now in this little example, we have a rise of -4 because we went down 4 and to the right 2. This can absolutely be simplified to -2. All right, number 1. Let's write the linear function in this slope-intercept form. So let's find the y-intercept and your average rate of change. Now the y-intercept exists right there. -2. B equals a -2. In order to find the slope, we need 2 points that we look at. Now, one point's already labeled as the y-intercept. The second point is going to be up here. It's at a tiny little corner where that diagonal red line meets the corner of my grid. That's what makes it a good point. All right, m is our slope, our average rate of change. Let's calculate it. It looks like you're going up 1, 2, 3, 4, 5, 6, 7, and to the right 2. Your slope is 7/2. That's all we needed. Let's write our function. F of x equals 7/2x minus 2. Let's do that one more time with the next question. Let's identify the y-intercept first. There it is, it's 3. And here's one more point to the right. Let's find the slope. It looks like I'm going down 1 and to the right 3. Whoops. So our slope is -1/3. When we're talking about slope, we only look at up and down for being positive and negative. We're always going to the right, and that is always positive. So there can only exist a negative number on that top of the fraction. However, if you wanted to, when writing out your function, you could write the negative out in front of the fraction. That would also be a correct and totally mathematically legal move. So our equation is -1/3 x plus 3. Great. All right, number 3. Number 3 we can do in several ways. So for letter A, I want to find the average rate of change, which is our slope. One way to do it is to use a nice little equation. Whoops. I'll show you what the equation is, and then I'll kind of show you a different way that I think is also pretty nice and easy. Here's the equation that we use to find slope. y2 minus y1 over x2 minus x1. Similarly to how we were doing second term minus first term when we were finding the common difference for arithmetic sequences, we're doing second y minus first y, second x minus first x. So what this ends up being is y2 is the second y, y1 is the first y. So -6 minus -12. I thought I could resist color coding, but clearly I can't. All right, for x's, this is x1, my first x, x2, my second x. So 0 minus -3. On top, negative 6 minus negative 12 is positive 6, and 0 minus negative 3 is 3. And that, of course, reduces to 2. Now, this is the other way we could look at it. Let's find the pattern for our y's. It looks like each time we're going up by 6. And for our x's, we're going up by 3's. That's still 6 over 3, which still gives us 2. Now for letter B in number 3, what I'd like us to do is find the function, or to model it. What we're missing here is our y-intercept, that B part. Now our y-intercept is always a 0, comma, y. In this case, it exists right here. 0, negative 6. So our function is 2x minus 6. We got the 2 from letter A and the negative 6 from looking at our table. To finish up this problem, let's find out what the value of the function would be at a constant rate of 15. What that means is, instead of x for this function, I'm going to be plugging in 15. So instead of 2x, I'm going to have 2 times 15 minus 6. 2 times 15 is 30, minus 6 is 24. Let's try that one more time. Now, for number 4, I absolutely added this in after I created the problem, so let's ignore that for a second. And instead of using the formula up here, the y2 minus y1, let's figure out the pattern without it. Okay, so again, ignoring the 0, negative 7, I should have added that in a different area, but it is what it is. Okay, so our slope is the change in y's over the change in x's. So let's see what our pattern for our y's is. Plus 2, plus 2, plus 2. 2 goes on top. How about the pattern for our x's? Plus 2, plus 2, plus 2. Fantastic. We got the pattern for our x's. I'm going to rewrite that plus 2 because that looks ugly. All right. So 2 over 2, which is 1. To model the function, we first need to identify the y-intercept. And the y-intercept is whenever x is 0, and that happens to be that extra point I added in, 0, negative 7. So our function is 1x, or just x, minus 7. Just like the previous problem, let's determine the value of the function after a constant rate of 5. That means we're going to take the function from above, and we're going to plug 5 into it. So f of 5 equals 1 times 5 minus 7, which is negative 2. Number 5. A tree is currently 10 feet tall and grows 2 feet per year. This is why changing the language of slope and average rate of change is so important. Because the tree growing doesn't necessarily have a slope, but it does have an average rate of change. What is changing? Well, the tree. It's growing. So our slope, our average rate of change, is 2. And in word problems, the y-intercept is called the starting point. So we're starting at 10 feet tall. Now, let's find out how tall the tree would be in 5 years by plugging in 5 into x. Two times 5 is 10, plus 10 is 20. But we're not quite done. We do have to write 20 feet after 5 years. Let's do the same thing for number 6. A tree is currently 4 feet tall and grows 6 feet per year. Let's write a function. Well, the average rate of change here is 6 because that's how much we're growing every year. The starting height, is 4. Let's find out how tall the tree will be in 10 years by plugging 10 into x. So we've got 6 times 10 plus 4. 6 times 10 is 60, plus 4 is 64. So 64 feet after 10 years. If you have any questions about this lesson, or I guess anything math related, please let me know. I'd love to answer those questions. Otherwise, have a wonderful, wonderful rest of whatever day it is for you. Bye!